Okay, so you should have viewed some examples of why the Pythagorean theorem is what it is. And I want you to see that the Pythagorean theorem is used to find the missing sides of right triangles. Okay? And our formula, excuse me, our formula right here is a squared plus b squared equals c squared. And what this means is it means the area of square A plus the area of square B equals the area of square C. I really want you to understand why the formula is what it is. And so right here we have some triangles. And so what this is saying is that we have some squares and we have a triangle. So it's saying that the area, a squared, that's how we find the area of a square, is a times a, or a squared. The area of this square plus the area of this square equals the area of the larger square. Okay? Now, one thing that maybe we haven't talked about yet is when we have a right triangle, okay, sides A and B are called the legs of the triangle. They are called the legs of the triangle. And then side C, which is always opposite the right angle, is called the hypotenuse. Okay, because that's really important. It's okay if we mix up side A and B, but it's not okay if we mix up side C. So it says find each missing area. Then use the areas of the squares to find the side length of each square. And so we have to feel really comfortable working between area and the side length, okay? So we're going to fill in the formula. So a squared. This would be a squared. I know this is a squared because it says 9 units squared. So 9 plus the area of this square, which would be 16, equals the area of C, or C squared. So 9 plus 16 is 25. Okay, and so now if I wanted to find the length of side C, then what we're going to do is we're going to take the square root of 25. We're going to take the square root. It says to find the side length of a square, take the square root of the area. So the side length of C would be 5. It says what are the side lengths of each square? Okay, so the side length of square C is 5. If I want to find the side length of square A, all I have to do is take the square root of 9. So side A, each side of the square is 3. B, the area was 16. The square root of 16 is 4. So the side of square B is 4, and then we already said that the side of square C is 5. Okay? So let's look at the next example. I want us to figure out what the side lengths are. So here is C, here is A, here is B. I know this is side C because if I draw an arrow, it will point to it. Well, we already know the area of this square, so we're just dealing with the areas. It's already squared it for us. So 225 plus, ooh, look, we don't know the area of B, so we're going to write B squared. And then we are, and I'm sorry, I don't think this is 2.25, 225. And then this equals 625, okay? So notice we've filled in our formula. We've got kind of an equation here. So now to solve this, to get B by itself, I'm going to subtract 225 from both sides. So the area of square B is going to be 400 square units. Okay, that is the area. Now, if I want to find the side length, then all I have to do is take the square root. So the side length of square B is 20. Okay, let's look at what the side lengths are of these. If I take the square root of 625, the square root of 625 is 25. You could test that with your calculator. The square root of 225 is 15. So side A is 15. Okay? Okay, let's look at the next one. Okay, let's try to identify our sides. Here's my right angle. So this is pointing to side C. So this is square C. Remember, we're filling in our formula. A squared plus B squared equals C squared. So if I already know the areas, which I do, then I don't have to square them. This would be square A. This would be square B. So this time we don't know square A. We know the area of square B is 144. We know the area of square C is 169. Okay, so notice again, to solve this, to solve for A, I am going to have to subtract 144. I get A squared equals 25. So the area of square A is 25. But if I want the side length, I then take the square root. So the side length of square A is 5. Now let's go look at our side lengths for these other ones. What is the square root of 144? It is 12. So the side length is 12. What is the square root of 169? It is 13. Okay, one last problem to look at. Again, notice I've given you the areas because it says 13 square units, 9 square units. Okay, this would be square C, this is A, this is B. So again, I don't know what the area of square A is. I know square B is 9, I know square C is 13, the areas. To solve for A, we're going to subtract 9. A squared equals 4. Okay, so the area of square A is 4 square units. If I want to find the side length, I then take the square root. So A equals 2. Now this is a little bit trickier. The side length of B, the square root of 9, that's easy, that's 3. But if I want to find the square root of 13, this is not a perfect square. I'm going to get my calculator. I'm going to go ahead and pull up Desmos. And I'm going to have to do the square root of 13. That is not a perfect square. So let's see, I've got the square root button, see the square root button, and then type in 13, and I'm going to have to approximate it. C is going to be about 3.61. Okay? So that's using the models, using the squares, using the areas to help you find the sides and the area. So notice, sometimes when we fill in our areas, we have to subtract. But sometimes, like in this one, we actually added. So it's really important that we take the time to fill in our formula so we know what information we've been given.